So this is the tutorial on how to do decision trees using Orange software. And as usual, the first thing I'm going to do is start Orange software. And the data that we will be using today is on Canvas, and it is called, so the data that we're going to use is called tutorial D-tree house. This is the house versus condo example, by the way. So you will download that, and I will just upload it from my system that I have. So a new workflow, and then a widget for CSV file import, and the data is here. This is my file structure, not yours. Totally different. So this is the data, and this is the data that I think I lectured about this, but I forgot exactly when. This is data on prices and square feet of real estate and whether or not it is a house or a condo. Okay. So as usual, we need to classify our data with data types. So this first one is categorical, and then these two are numeric. If you don't do that, you will not be able to get anywhere in Orange because Orange has no idea what the data types from a CSV file are. Okay, so there we go. Categorical, numeric, and numeric, the data types are set. Okay. Now, we don't need to do distances with decision trees because decision trees are not based on distances, which makes them slightly easier. The other gigantic advantage of decision trees is that you can throw categorical variables and other things in them because you don't have to use normalized data. So that is one advantage to a decision tree. So the next thing I'm going to do, though, is because it is still a model, I'm going to do these select columns. And I'm going to flow the data into the select columns. And I don't know how it's set up. Like, somehow Orange senses things, and sometimes this is set up correctly and sometimes it's not. So our quote target output category variable is type because we're going to build a model to predict type. It's going to be a decision tree model, but still a model. And the inputs are square footage and price. Okay, good. So that is all set. Optionally, it's nice to view the data, and the reason for that is you want to see like what kind of separation you have. Let's go ahead and do a scatter plot and flow the data into the scatter plot. And this is simply looking at the data. It's somehow Orange senses to do this, like it's all labeled. So it's labeled by type, house, and condo, and you can kind of see that this is data that there's a nice separation in. So the houses are, good question. I believe the houses are red and the condos are blue because the condos are less expensive. So show legend, that's always a good thing to check. There you go. Yeah, house and condo. Okay, so this just, to always sort of keep in touch with your data and like look at it is really, really a good idea. Now I'm going to sample the data. So I'm not sure if you watch these, if you watch the KNN one first, that does this as well, but this might be the first time you do that. So there's a widget called Data Sampler. This is what's going to split the data into test and train. And Data Sampler is, I forgot. Mine has so many widgets on it. Like, I'm like, where is it? Where is it? Where is it? Where is it? Data Sampler is under Transform. Okay, good. So there's a little dice in the corner. So I'm going to run the data to Data Sampler. What Data Sampler wants me to do is to tell it like what percentage of the data to use as a training and testing. I would never go with like less than 50% for making the model, but I'm going to go with 70% because it's kind of a small data set and I want to have like enough to test. So I'm going to split the data 70% training and 10% testing. And you have to click this little sample every time you do this. Now this is randomized, so if you do it on the same data, you might get a different result because my 70% pulled into training might not be the same as yours because it is random sampling. So notice that. Okay. And then what I'm going to do is I'm going to add a tree. You're like, what? The output here, I'm going to go to model and it says tree. This is decision tree. Okay. I know that hierarchical clustering kind of resembles decision trees, but it's not. So now I'm going to flow what's going to flow into the decision tree is the sample data, not the remaining data. So this is going to be the 70% going into the tree algorithm. The tree algorithm wizard is under model, which is part of the orange defaults. And then when I click on this, it does nothing because you think it will show a tree, but this isn't actually showing the tree. This is like making the actual model thing. And so to actually look at the tree, I want to go to the visualize, and there's this thing called tree viewer. That's how you view the tree. Okay. So this is exciting. Let's look at the tree. So this is the tree that I get based on the sample, and what it's doing is the top is, so ultimately what we want to do, because the way that we set this is we are selecting, I don't want you, I want you. So we're selecting our category is target, and we're using square footage and price to determine target, and we're trying to do a decision tree with these two inputs and this as our ultimate goal. And so let's look at the tree and try to interpret it. So the first split is based on price. So if you're under 265,000, you are a condo. And if you're over 265,000, or if you're over 265,000, then it's split on square foot. Although in this case, I have to admit, it doesn't have to be, because if you're over 265,000, that's what this is saying. Price is the first split, and then square foot's the second split. So if you're greater than 2850, your house, but if you're less than 2850, you're also a house. So you actually don't really need. So we could actually change the depth here to 2 levels, and really that would really be like all we would need. You want to actually see your results. So that is a decision tree. This is a really, really easy one. These leaf nodes at the bottom, and then this is like the interim node, and then this is like the top of the tree. Decision trees are sort of like fairly easy. They're not like super complicated. Okay. So now that I have this is one sample, but if I went back and redid this, it's entirely possible I get a slightly different tree because it's choosing a different sample. And I got a slightly different tree. So in this case, it's split on price. So less than 257 is a condo, greater than 257 is price. And then it's splitting on square foot. And here I actually see, then it's splitting on price again. So price greater than 550 is a house. Less than 550, then you need to go and use square footage. Square footage less than 1330 gives us a condo. Square footage greater than 1330 gives us a house. Remember, we have a different sample, so we do get slightly different results, particularly the small data set where a couple values can bias it. Okay. So the other thing I want to do is evaluate how good my model is. Okay. And the way I'm going to do that is I'm going to use predictions and a confusion matrix. So I'm going to go down to evaluate. I'm going to go to predictions. Okay. And I'm going to also add a confusion matrix. Now the way I want to hook this up, be very careful about this. When I did this sampling, 70% of the data went to make the model, but the other 30% did not. So the 70% that goes to make the model flows through the model and then flows to predictions, input output. But I also want to flow the 30% that's testing to the predictions. And so this one, I want to make sure that I want to click on this and be very careful about this one. So this one here, this is sample, which is what I want. but I want to send the remaining data, not the sample, to prediction. So I want to change this. And this is the 30% remaining data that I'm sending here. Okay. And now what this is doing is it makes the model and then it's applying the model to the remaining 30% predictions, which is these 6 values here. And what we see is a classification like accuracy thing. And so we have condo, house, condo. So these two right here are actually being misclassified. This is the data. And so these are the 6 that got pulled from the data to be the test. The other 14 in the data are the training. I think this is 20 in this data. But there are some misclassifications here, which happens. And you should, I mean, in general, you really should have some misclassifications. A perfect model is not ideal. And so if you have a really perfect model, it can mean that your model is like overfitted. And so predictions, the confusion matrix really just summarizes this. It's just that it's easier to look at it in a matrix form. So in the confusion matrix, we will see there's actually 3 misclassifications. I didn't notice that. So this isn't the greatest thing in the world, is decision trees. So there's actually, there's this one too. So there's 1, 2, 3 misclassifications. So the model has an accuracy of 50%. That's not really fantastic, but I mean, it is what it is, because it's better than nothing. It is a tool for looking at things. So you could actually let's go back to sampler and see if we can do a little better. So let's sample and sample data. So now it's going to redo it with a different sample. Let's just see if I get something a little better. And I get something a little bit better. Now this one only has 1 misclassification. So this is it's such a small data set that it's really sensitive to like which ones get selected. So, and again, so we'll only see 1 misclassification, which is this one right here. Because this is a condo, it got misclassified as a house. And you can see that in your confusion matrix right here. That's this. Okay. Now, this, on the bottom of this also is classification accuracy of 83%. That's pretty good. But again, these are super small data sets, so it's not super like perfect. Other things you can do with this is you can prune the tree. This is in the tree. When you apply the tree algorithm, I don't know what induced binary tree does, to be honest, but you can do things like limit the maximum tree depth to 100. Now this is like if you have a really giant data set. In a small data set, you're not going to notice this. The minimum number of instances in leaves, 2, that means that you can't just clump all the data together in one. Do not split. This is actually important. In order to avoid overfitting, you don't necessarily want to split data if there's like smaller than a certain number of data values. Like you don't want to split things into like groups of 1, because then you're fitting a data literally to the data itself, which isn't really the idea when you're classifying things. So you can play with these, and then tree viewer. When you're here, you can also sort of play around with it a little. This just adjusts the screen. Edge width, I don't know what that does. These are just display issues. Target class, you can just show one as the target and not the other. Like this one will be blue, and that's none. It's color coding. Now the target is house or condo, and it's coding them. This is a nice, super simple one. It's just saying that if you're less than 300,000, you're a condo. If you're greater than 300,000, you're a house. And of the 16 inputs, most of them fit into these perfectly. And you can do another level here, but I don't think we're going to see anything in another level. So these decision trees, again, I mean, a lot of this data mining stuff is like super exploratory. You get what you get, and you can get at least something interpretable with a lot of data. Decision trees might not work super well for some things. Like you might just get like sort of like something that's 20 levels and not very interpretable, but you can kind of work with these, and you can kind of like trim them and prune them and resample and look at them. Because remember, in data mining, you're looking for patterns, and you are, in fact, when you do this, you are seeing that there's a pattern where if it's less expensive, it's a condo, it's more expensive, it's a house. And that's really the whole point to this. And then if you come up with something with good prediction, you can use that as an algorithm to classify new things as well, which is wonderful. If you have a terrible prediction, like the one that we just when we did the first run and it was 50%. You probably don't want to use that for like predicting. I mean, houses and condos is two categories. You probably don't want to use a model with a 50% prediction rate, but an 83% accuracy, that's decent. I mean, ideally you want wonderful accuracy, but you're working with data and you're doing exploratory things. So um, that is the gist of how to do a decision tree in Orange. They're kind of fun, but again, the super scientificness of this compared to like statistical modeling in a statistics higher level course is not. This is very exploratory, but it's fun. All right, so that was the tutorial on decision trees, and I have for you two of these to do on Canvas for exercises, and that is the work. Okay, there is one more tutorial video on evaluating these, and that is it for this. I know this week is sort of like kind of intense on the algorithms. These are the last remaining algorithms you're likely to use on your project, so we're basically kind of done with the major algorithms. The week 7 stuff is association analysis, a little different. All right, thanks.